think the other day we were printing this just to kind of get you ready. So I think I put Wednesday night. 22nd would be Wednesday night. I'm hoping you'll have everything you need. So I would go ahead and, if you didn't print it in here the other day, print that PDF, because that's kind of what or did y'all print it? I'll do a couple and set them up here. So you should be able to do the first one, which is convert a bearing of south 87 degrees 15 minutes 02 seconds west to a north azimuth, and then you should be able to take a north azimuth and convert it to a bearing. And then we'll work some like these today, just to kind of tell you what's the difference between a bearing and a north azimuth, what's the difference between angles. So this is bearing, angles, and azimuths. All right, I'm going to go ahead and put my north, south, east, west up. What quadrant is A to B in?
Quadrant 3.
So basically that's the reverse bearing. So the bearing is the angle it makes from the south. So that's the 31 degrees, 10 minutes. What quadrant is B to C in? Quad 2. So the bearing is the angle it makes from the south, and that's what we're looking for. So we've got the bearing from A to B to south as 31 degrees, 10 minutes. We actually have the angle between A, B, and C is 96 degrees, and that's 18 minutes. How can we solve for the remainder? How can we solve? We've got the total angle between the two, and then we have the angle from the line to the south. How can we get the bearing on that line, which is what I'm looking for?
You do 96.18 minus 31.10, and then the bearing would be south, whatever the answer is, east.
So because we had the whole angle, we had this, we just subtract out this, and that's leave us with what's left over.
65 degrees, 8 minutes.
Yep.
And then it's coming from south going east, so it's south 65 degrees, 8 minutes.
Yep. So that wasn't too bad. You got one bearing, because you know if the line is in quadrant 1 or 4, the bearing is the angle it makes from the north. If it's in quadrant 2 or 3, the bearing is the angle it makes from the south. A bearing can't be over 90, and we need 2 letters. Can I flip over one? Everybody got that one? I'm going to do another one. That's your south.
If it's directly to the east or directly to the north and you want to write it as a bearing, do you just write N or E?
So if it's directly to the north, I would put 0 degrees. I would put north 0 degrees east, or I put north 0 degrees west.
Okay.
They're both technically correct.
Okay, because I was looking right here, it's got a bearing of N 35 east plus 55 degrees is exactly due east. So I would write south 90 degrees east or north 90 degrees east.
You talking about if they go straight?
Yeah.
East?
Yeah.
Yeah, I would either put south, south 90 degrees east or north 90 degrees east. Either one would be technically correct. And then the 90 is the biggest it can be. Alright, like I like to put my north, south, east, west up. So north, south, east, west. Quad 1, 2. Okay. Alright.
Does that say 265 or 565? Oh wait, no, that's an X.
That's the south, I guess. That's south 6508. So that's the same one we just solved a little while ago. So now I'm going from, so if we were coming B to C and we were on this page, it was in quadrant 2. Now I'm taking that same line. What quadrant is it in now?
It's in quadrant 3.
This one.
Oh, that was in quadrant 4.
Okay, so the bearing is the angle it makes from the north. And what quadrant is C to D in?
C to D is in 3.
So that's the one that we're looking for. So we've got the angle from north, because if it's 1 or 4, the bearing is the angle it makes from the north. We have the angle between the two lines, and we're looking for the angle that C to D makes with the south, because it's in quadrant 3. So how could we solve for this angle here? Maybe 180 minus those two added together. Because the line's got to be 180 degrees. We know these two angles, so we can add them two together and subtract it from 180. And I'm going to go ahead and write south and west. Anybody want to punch it in and tell me what you get?
How is BC southeast? It seems like it would be northwest. It's in quadrant 4.
It is in quadrant 4.
It's quadrant 4.
But if you are at the B end,
Oh, I see. Okay, I'm sorry. Thank you.
that's a good, because if it's that. So if you're at B looking to C, it's in quadrant 2. But if you're at C looking back, it's in quadrant 2. So those are the two angles. So every line has two directions.
Okay. So
That's why we were getting the reverse. We were adding the 180.
So you really gotta pay attention, like which letter comes first. If it's C to B or B to C, it's gonna be it.
And then when you draw it, don't get hung up on that it says southeast. Because technically, I like to, when I label stuff, I like to have, there's like a little directional error.
Okay.
I do like that on some of the plats that I do has a directional error. Directional. They don't have it on theirs. And so when you see all of them labeled one direction, because how Pat labels it, you put it in this way, you're not going to get it. So they label All this is labeled, but it doesn't have directional. You just have to look at northeast to see how it goes. I think I have some that has, like they don't have directional errors, but you can put a directional, because depending on, unless you know where north is, you gotta kind of look over here and say, okay, this is north. Yeah, and look back.
You put it just to the calculator like that, and that's correct.
Yeah. Yeah.
But it doesn't have to put the actual degree system behind the one.
No, you don't in any way have to add the, after the 8, or did it come in for you?
Yeah, I just typed in exactly that, the 180.
Yeah. So it was 38 what?
38 degrees, 8 minutes, 0 seconds.
I think I have a plat that has directional errors on it. Arrows, not arrows, arrows. So we're solid.
So if it's exactly on the line, like the 90 degrees or 180 degrees or 270 or 360, how do you mark the southeast, northwest?
So if it was, which way?
If it's exactly 90 degrees, like if,
Over here?
yeah. But if it's on the line, how do you know which letters to put on it?
You either need to give it southeast 90 degrees or northeast 90 degrees. You give either or.
Oh, okay. So both are correct.
Mm-hmm.
Okay.
All right, so mine has directional errors on the line, so I can tell you which way it's going to all of it.
Yeah, but that's fine, because you can see them. That makes sense to me. Okay, because I was looking at that picture
And
on.
some of them don't, like both of these are going straight up, that's going that way.
Okay, so you just made it northwest.
Mhm.
Okay.
And that's going that way. So I only put directional errors. You can, when you label, it gives you a choice to add a directional error. That way you know which way it's going if you're trying to put something fast.
Oh, I see it.
Yeah.
But this is what I was talking about, like if it's 0, like it could be northwest or southwest.
Oh, okay,
And
yeah. You always want to do north, so it'd be northeast or northwest.
Yeah, that's what I didn't know, if it was exact, how do you know
Just a
which
bunch of zeros.
But it doesn't matter which way, like it could be
Yeah.
N or S.
Because you want 2 letters. All right, so we got, for this one,
I
we
got one more
got
question about that. If you,
3808.
I got one more question about the due north or due east,
Mhm.
due west. So if you go, if you're exactly on, like, say, the east azimuth,
Mm-hmm.
and if you say north 00 east, or north 90 east, excuse me, do you have to do that the whole time? If you come up on another example where it's due east exactly, can you go south 90 east?
You can use either one and you're right.
Yeah, but if I use one time, it's okay if I use the other one the second time, because
Yeah.
it's exactly the same reading.
Yeah.
Okay.
So you might want to use whichever one would make
It's
it
still the same thing. It's still going to be straight. It's just, if they want to put a letter. So that one was south, 38 degrees, 08 minutes west. And I got the west right be over here. So. All right, so let's look at something that gives three bearings and it wants all the angles. Try to draw it a little more toward. Compute all interior angles. So I want angle A, angle B, and angle C. I'm going to start with A, and I'm going to do my north, south, east, west. 1, 2. So A to B is in quadrant 1. So that's the angle it makes from the north. So that's your 81 degrees, 56 minutes. All right. A to C is in quadrant 2. That's 72 degrees, 27 minutes. And I'm looking for this angle. So if you sketch your north, south, east, west, and I look, of course, I know that the first one's in quadrant 1, so the 81 degrees, 56 minutes is the angle it makes from the north. And A to C is in quadrant 2, and that's the angle it makes from the south, so that's the 72 degrees, 27 minutes. And then I'm looking for the angle between the two lines.
So you would add the 81 and the 72 and subtract that total from 180.
Yep. So you would add these two, and to figure out what's left, it's 180 minus those. I got 25 degrees, 37 minutes. Somebody check that. Somebody else get a check? You're checking it now. I need to circle that this was quadrant 2, so it doesn't look like it's just a generic.
I got 25 degrees, 37 minutes.
Yep, that's it. So I'm just going to list it over here as, that's my angle A. Okay, I'm going to B. If I'm looking from B to A, that's in quadrant 3. So the angle the line makes with the south is 81 degrees 56 minutes, because that's in quadrant 3. And B to C is southeast, so that's in quadrant 2. So that's the 11 degrees 52 minutes. And I'm looking for the angle between the two lines. I'm looking for between blue to blue. What do you think you would do with that? I got,
So you would take 81.56 plus the 11.52, and that would be the angle.
correct. You would just add the two angles. .93 degrees. I got 48. Did I write something wrong? Put it in the calculator instead of trying to do it by hand. I got everything written down right. 81.56 and 11. Oh, yeah, 11.52. Degrees. .93, 48 minutes. 56 and 52 gives me 108, and then we subtract out 60 would give me 48. So yeah, that would be right. And then I'm gonna pull this one down because it's kind of hard to see, so I'm gonna pull C down. All right. South 11 degrees 52 minutes east. That's B to C to D. That's in quadrant 4, so the bearing is the angle it makes from the north. So we've got that. And then this is still in quadrant 4, so this is the 72 degrees, 27 minutes. And I'm looking for the angle between the two lines. So I'm looking for this.
You do 72 minus the 11.
Yep. So you take your 72 minus your 11. What can we do to make sure that we're right?
Add all three of those together and it should be 90.
You sure 90?
Oh, 180.
Yeah, 180.
Check.
Number of sides minus 2 times 180. So you could add them all together. And I would, if it's a test, I would check, I would add them together and make sure they equal 180.
Number of sides times 2.
Number of sides minus 2
Oh, minus 2.
times 180 is your interior. And if it's exterior, what would that be? For exterior angles. Number of sides plus 2 times 180. I'm going to add these together. Got 180. So that's a plus. And then I'm going to do a big one. Okay, good. Think you're kind of good on this? Maybe work a bigger one with giving your bearings and wanting your angles. And then we'll do one last one like your last one, which gives you one line, and I want all the other interior angles. Or I want all the other bearings. What are all the interior angles? So I want all interior angles for this. If y'all want to take a break while you're writing it up, and then we'll kind of go over it.
Okay, so I know that you can use the trick adding two angles together and subtracting the sum from 180 to get the third angle in a triangle. But can you use the same principle for a shape with four sides? Like if I know that
Number of sides.
the number
minus-
of sides minus 2 times 180 is
Correct.
supposed to be all the interior angles. If I
Yeah.
get three of them, can I just subtract to get the fourth?
Yeah.
I don't know why I'm thinking my work, but I think that might not work. It sounds like it works.
But if you got any of your others wrong, that
Yeah.
would be the only thing. If you got one of the others wrong. So when you look down and found the marker, you just have to be standing and see one of the geodetic or see one of their markers.
Yeah, it's right in the middle of the sidewalk. I should have taken a bigger picture, so it's
Oh,
just,
no.
it was literally right in the middle of the sidewalk.
Kind of like we had the ones made, they had them made for our technology.
Oh,
Yeah, I like that one. I look at it and I'm like, hang on.
Had them made for the technology. She went to Disney World and they had the markers set there and then had it like a little scavenger. And then, she found out that they had surveyors on staff.
20 surveyors on staff.
Wow.
Just at Disney World.
That's cool.
So tomorrow, we won't have lab day. I've got some tours that are coming through, so I'll just give it to you all. Unless by chance Mr. Villanelle comes up and can do it, but I doubt, I didn't see him say anything about it.
It's just right in the middle. So right where
In
the
the middle,
dead
that's where you put it.
center, that's where the commission is.
And you said they had a little scavenger or something.
Oh, no, just people made it.
No. So the surveyors are just like part-time at Disney?
No, they've got 20 full-time.
Oh, they hired themselves.
Yeah. They have 20 full-time surveyors, but it's just constantly in a state of,
What was the Disney surveyor?
so it just, like people have somebody. So she did this little. So somebody has done this, so they've gone around the park and found all of them, but.
And then I'm gonna tell you where you're,
Yeah.
exactly where you're in the park. Okay, that's
So.
cool.
Where it is right there, so you're just walking in and out of the anticipation, the big globe things right behind you.
So you don't even look before it just
No,
happened
it
to
just
see it?
happened,
Oh, yeah.
we were just walking down the
And now that I know what they look like, I have noticed a few, like on a light pole or something, where they have, and they say one's nearby.
So this one is just in the parking lot as you're walking in. So it's just.
And now that we know that they're there, it's more fun when we
So
see them.
she's got the pictures like this, but there's another geek which will put
Oh, I can look at them and show you the.
yeah, it was like a GIS.
All right, so angle A. I got north, south, east, west drawn up from A to B is in quadrant 1. So that's 39 degrees, 16 minutes from north. Quadrant, so from A to D is in quadrant 2. So that's the 70 degrees, 13 minutes. And I'm looking for the angle between the two lines. Gil, how would you solve that one? I got the angle from north to the black line, which is 3916. I got the angle from south to the other black line, which is A to D is 70 degrees, 13 minutes, and I'm looking for the angle between the two lines.
So it's 180 minus those two added together.
Correct, because you're looking, because if it's a straight line, and the first one, because if it's in quadrant 1, the bearing is the angle it makes from the south. So that's what we had right here. And we drew that one. We found out that was 70 degrees, 13. And we wanted this. So all three would have to equal 180, a straight line. So we would, I normally just put it all in the calculator at one time and say 180 minus those two.
So I got 70/31.
Mm-hmm. I'm going to circle that one. So for A, 70/31. Now I'm going to go to B now. 1, 2, 3, 4. B to C is in quadrant 2, so that's the angle it makes from the south. So there's your 11 degrees, 42 minutes. Quadrant, so B, looking back at A now, is in quadrant 3, so that's the angle it makes from the south. So that's the 3916. And I'm looking for the angle between the two lines. What would you do? Miguel, what would you do to get the angle between those two lines? What if you add the 39 to the 11? That would give you your total angle. So you would add your add 50. So you can kind of see a pattern. If you have two lines that are in quadrant 2 and 3, if you have two bearings on two lines, the angle in between is just going to be added together. If you have two that are in 1 and 4, same thing, you're just going to add the two together. If you have some in opposite quadrants, like 1 and 2 or 3 and 4, that's when you add them together and subtract from 180. If they're in both the same quadrant, you just subtract the bigger from the smaller. Kind of like what we're going to do in D. I'm going to wait and I'm doing D last, or D next. Okay. Okay, these are north, south, east, west. That's in quadrant 4, so that's your 13 degrees, 16 minutes from D to A is also in quadrant 4. So that's the 70 degrees 13. So if I want to find the angle between the two lines, I just take the bigger minus the smaller. So if they're in the same quadrant and you're looking for the angle, you just take the bigger minus the smaller. And I had 56. No, it's not C, that's B. And A. Now I'm looking for C. What quadrant is C to B in? So the bearing is the angle it makes from the north. Okay. And then what quadrant is C to D in? 2. So that's your 13. I'm going to do it bigger on a different page real quick, just to kind of let us see a little bit better. Okay, so north, south, east, west. C to B is in quadrant 4, so that the bearing is the angle it makes from the north. And now I want this angle. I'll tell you what I did. I solved first to right here, and then added the 13. So if I knew this was supposed to be a straight line, I took 180 minus the 11 degrees, 42 minutes. And that gave me the rest of that angle. And then you can add your 13/16. I had 181.34.
You got what?
181 degrees, 34 minutes.
Shoot, why do you want 33? I did something wrong.
So if I took, because I think I just did 180 minus the 11 degrees, 42 minutes. Okay, when I got that, I added the 13 degrees, which would, and 16. $181.34. So now if I add all four angles up and numbers up minus 2 times 180, I should get 360 degrees. So if I add my 7131, my 5058, and my 5657 plus my C, I should get 360 degrees because there's four sides, 4 minus 2 times 180. When I did, I got exactly 360. Now I think when I was hearing Genevieve talk about it, I think she figured all three, all but C, and then just took it from 360. So instead of, if she wasn't quite sure how to do the C, she took the other three angles, added them together, and subtracted from 360. But if you have a mistake in one, then it's going to make a mistake in something else. So I wanted to try to do them all and then add them together. Homework, not so much. Test, yeah, I would check it.
What did you get for the last one again? What for 181.34?
One like the
I'm off 5 minutes. Can you go back to that other picture? Alright, so D is 5657. A 7031. B 5058.
Where are you getting a 62?
For some reason. 632.26. Yeah, like, well. $3.16. Okay. Thank you.
Okay. Next one up. You get the other two angles and then I'll put it up there. And we're gonna be looking for bearings on all the lines. Gotta get the last two angles back. Make sure I don't make a mistake writing it down. Okay, so I got it right. I want bearings from A to B, B to C, C to D. You're given all four interior angles. They do close, so they do add up to 360. Okay, so A to D is in quadrant 3. So the bearing is the angle it makes from the south. So there's your 29 degrees, 16 minutes, 30 seconds. Line from A to B is in quadrant 2, so that's the bearing it makes from the south. So that's what we're looking for. We've got the total angle, which is 106.27 minutes, 10 seconds. We know the angle from D to A to south, which is 29 degrees, 16 minutes, 30 seconds. We're looking for what's left over. So in other words, you have that. I'm just going to leave it where it is. Can y'all see it pretty good if I'll just leave it in the, oh no, I didn't mean to slide that. I don't know how I slid that. I don't know how to get it back.
You could try hitting Control Z.
Try Control Z. So like hit undo.
There it is.
Okay. Good thought. So how can I, if I got the total angle from the two lines is 106.2710, and I know what the angle from south is for A to D.
You would take 106 minus the 29.
Yep, and that'll give you what's left over. So I'm going to write it on the line south. So we got 46 degrees, 06 minutes from angle to angle. A to B is now in quadrant 4. So the bearing is the angle it makes from the north. So that means we know that angle. And from B to C, that's an angle, it's in quadrant 3. So the bearing is the angle it makes from the south. So that's what we're looking for. So we can take 180 minus the addition of those two. Which should leave you 38 degrees, 43 minutes, 20 seconds. So you've got, so north, south, east, west, C to B now is in quadrant A. So that's the angle it makes from the north, which is 38, 43, 20. You have the entire angle, and your C to D is in quadrant 4, so we're looking for this.
So you take the 102 minus the 38.
Yep. Gave me 64 degrees. So now I've got bearings in all 3 lines. What I would do right here, I would add this, this, and this, and see if it equals 180. Then I know it didn't mess up coming all the way around. If all 3 of those equal 180, which we aligned, then we're good.
And last one was northwest.
Yes, it is northwest, not south.
Okay, sure. I was like, oh man, I thought I was getting it, and then I saw that as S, and I was like, oh my God, I'm not getting it.
It is. Oh, I don't know what I just did. I hit shade. See if Control Z works again. And if you add all 3 and you get 180, then you would know you're good. So out of this, is there anything else? We just covered just about every single thing that's on here. So I'm looking for bearings, looking for interior angles. I'm only asking for B and D on that one. I'm looking for all interior angles. This one, I want the bearing from B to C. And this one I want from C to B. So if you give it to me, if you figure it out and you have B to C, then think about technically what would that be from going from C to B.
And is this just an assignment or is it our like next test?
It's an assignment, but I can let you, it's assignment. I got it due Wednesday night because the next, there was one like a test, but I don't see. That's latitude and departures.
Are we talking about the surveying 110 exam number 2 is due on Wednesday? Or are we talking about something else besides that?
There's two ones. There's an exam and the homework. Are they both due Wednesday?
That one that says trigonometry, angles, azimuths, and variance, is this assignment that's due Wednesday? I printed it out.
Okay.
Yeah.
Yeah, that's,
That's the homework assignment, I gotta look at it.
Was it maybe
but then there's exam number 2.
on there?
I don't have that up there.
Exam number 2?
It might be because I've already turned it. Not on my calendar, I don't see it. What's the trigonometry? It's under module 5 and it's trigonometry, something.
That was 4, and that was the trigonometry one.
I don't know, I printed out 2 things.
Okay, so let me look at my.
Oh, right there, review test.
The trigonometry test.
That doesn't say test 2, and it's.
Yeah, if you click on it, it comes up and it says exam number 2.
No, that's not that one. That's definitely not that one. I don't.
I have 2. This is the homework one.
Yeah,
and
that
was
is,
the
that is a
exam.
test. But I
So
don't know
when-
how it's, I don't even know where it's at.
It's under that link right there. This one.
That's the multiple choice one.
Oh,
That's that one. That
I
y'all-
see a test number 5 up here in the,
I must have it hidden somewhere.
how did I find it
I
then?
might have still had it open or something.
Is it under 5?
Mhm.
Oh, it's under 5.
Okay, but I don't. That's what.
No, that's the teaching one.
Yeah,
That,
That's
it's got all the pictures on how to do it. Test paper, that's it right there. But it says test 5 there, but nope, that's not it. I printed that out too. There's the assignment.
oh, that's called exam 2. I said that was extra work, is what that was. But let me see where, because I should have one. That's called
An
makeup.
extra assignment.
Yeah, that's
Oh,
all.
okay.
Under module 5, and then it's under trigonometry, angles, azimuths, and bearings. It's the
Yeah,
file
so
under
this
chapter
is,
diversity.
that's the one that says exam, and then the next one down is that's the homework one?
No, go up.
That was an extra assignment,
Okay.
but it's labeled test 2.
But it's not due, it was just for extra
Okay,
practice.
that, what you have open right there is what I have in my hand. I thought that was due on Wednesday.
No, that's the extra assignment.
Yeah, I don't even think I have I don't think I have a due date on it.
You're under module 5?
Yeah. Let's see if I had a due date. No, I didn't have anything. It was just that some didn't get the other in on time. This might have been the test. So I think because I reviewed the homework once you got back to get you ready for the next one, then if anybody missed the homework and didn't get it in on time, I gave them a second assignment, but they
Okay.
weren't gonna do the one that you guys
That you
did.
already reviewed.
Yeah, we already reviewed. So I think this might be the test, but it shouldn't be due. And that's, I probably should say, and it was a test just to kind of get y'all ready for it. Both of them are good examples.
Wow, this must be big.
Mm-hmm. Oh, that's so slow. Let's see.
Odd. Oh, just move further. You can do it. Okay.
It's not gonna. All right, I'm gonna save. Is there anything else that you can think of?
Expectations, resources, chapter 7, chapter 9, chapter 10. Trigonometry, That's, yes, that's the reality.
See if y'all can open that one.
I just did.
What does it look like?
Which I double registered.
I think this one has was. Here's exam 4, it's hid, so this is gonna be like what your test is like. So just like the homework stuff, so I just don't have it where you can see it.
Oh, okay.
So it's under, this is just an extra assignment for some. Maybe I need to make sure to say.
Yeah, that angles, azimuths, and bearings, it's not an assignment, it's just like a little practice PDF thing.
To show you how to work stuff.
Yeah.
I probably should kind of group them together. That's the original one. So I got the 29th, and I'm going to move this one up.
Practice more.
So this is the assignment,
Yes.
and this is extra credit? Or
Yes.
practice?
Extra. Yeah, extra. You can do extra credit.
Okay, well, I just did that. I thought this was the one that was due, so I just did that, so I'll go ahead and give that to you.
Okay.
And I'll just-
So today was a good practice day. Kind of go group and staple it too. That way it don't get apart from each other. Just trying to group this stuff together. This is the hardest. After this, it gets easy. All right, chapter, I'm just gonna do a quick overview, got 5 minutes, just to do a quick overview of what we're doing. Nine are examples of traversing, just like you did outside where we traversed around the building. Those were all examples of how we could have traversed. So traversing, we just did in the field, so it really doesn't have, when you actually were locating points and we located, set up on one and shot as many building corners as we could and shot up and stayed on 4 and shot as many building corners. That's what you would call radial traversing. So we're going to have notes for that. So all of this stuff, you know, we were traversing, we did our angles in the field. That's all 9 is. I did an introduction video for azimuth angles and bearings. And I'm gonna add it in today. I'm gonna add today's in too, because today's a pretty good practice. And chapter 10 is like a continuation of what we're doing. It's just you're going to start adding distances in. So once you get the preliminary azimuths or angles, we're gonna adjust them to mathematically make them close. We're then going to do preliminary azimuths for all the lines. And then we're going to figure out what the misclosure is. We've got formulas for that, and I've got a chart that has the preliminary azimuths, the lengths of the line, and you will solve for departures and latitudes. And once we get the departures, we'll actually balance them and then get our coordinates. So that's going to work. We've already kind of done the first 2 steps of this with your traverse. First, we mathematically made them close. I took everybody's mathematically made them close by adding to or subtracting from each angle. Secondly, last Thursday, we got the preliminary azimuths on all the lines, and then we averaged all of our distances so that we're ready now to put it in our latitude and departure sheet. When I did that, there's a sheet that has this in. I've got it in there. I've got the adjusted sheet right here, and it had the formulas in there for us. So I started, I did side 2 to 3, so I did it like yours, 3 to 4, 4 to 5, 5 to 6, 6 to 1, 1 to 2. I did all the preliminary azimuths, and then I did all my average lengths. The next thing I would have to do is my departure and latitudes. This doesn't, and there's the formula. L is the length, and the sign that looks like where y'all were asking me what that was. I'm not sure the Greek letter, but that's your preliminary azimuth. That's what this is. So you would do your length times your preliminary azimuth, the sign of it, and then you would put that number in your departure. You would go all the way down, and then we would total it up, keeping the sign. Same would be for latitudes. The only difference is the cosine, the azimuth. And then we'd have the 2 errors that I'm going to do like during the, so I will, no Tuesday, but yes Wednesday. I'm going to start doing a misclosure from beginning to end. Like work the example in the book from beginning to end in chapter 10. That way, when you come back the Tuesday after, we should then be able to do our sheets, and then we should be able to adjust our coordinates, and we should be able then to get our misclosures and then start our drawings inside. And it'll probably take 2 days to do drawings. Questions? No tomorrow. Yes Wednesday. If you're online Wednesday, that's fine. If you're in person, that's fine. I know some people travel.
No lab tomorrow or no class?
No lab, no class. Yeah, because I've got that. I don't think, unless I see Mr. Mill, and he's gonna do it. And I'll see him this afternoon. I didn't see him the other day once they came through.
Alright, so no class tomorrow, and what are you gonna do on Wednesday? 'Cause
I'm gonna do start chapter 10. You can follow it from the book. It's,
But remote is okay?
yeah, remote is
Yeah,
okay.
I've got
Yeah.
so much going on.
Yeah, remote is okay. And then if anybody's got questions on the assignment that's due Wednesday night, send me an email before Wednesday's class so I can cover that. If there's something you think you need me to do another example on, then I will before I start the chart.
Let me see, for construction estimating, did you ever post that video showing how to do homework 2?
No, I was gonna do it today.
Okay, I was just making sure because it said it was due Friday, but then I watched your collaborate, you said you would go over it, so I was just making sure.
It's due last Friday.
Yes, it said it was due because I did the chapter 5 assignment 1,
Mm-hmm.
and then I seen that it said that was due too.
Yeah.
So it did say that it was due Friday, but I knew that you didn't actually want to do Friday.
No.
And then I'll see y'all later.
Good.
I will be right here, I'm not going nowhere.